Jose is actually gonna do a demo on Tilt to show us how we can actually test locally.
I put together a small repository. I will use it to explain how Tilt works. Later on, you can experiment with it if you want. But now let's focus on the demo itself. And if you have any questions during the demo, just shoot. Don't wait until the end. We can discuss about it and talk about it because I just have tried Tilt a little bit, but I'm not an expert by any means. So let's figure it out together. Okay, so basically the first thing is to explain what Tilt is for. And Tilt is a tool that will allow us to have a quick feedback loop when developing locally. So the main idea is that instead of compiling your application, building your Docker image, deploying to Kubernetes every time you do a code change, Tilt would automate all of that and do it really, really quickly. And the main goal for Tilt is to make this feedback loop really, really quick. So that's the main thing. It offers other things, but the main goal is to make this feedback really, really fast. So in this repository, I have a couple of folders with different configurations. The hello world that I want to show you is a Tilt file. A Tilt file is what Tilt uses to see the configuration that you have for a specific project. And the Tilt file uses a programming language called Starlark, which is like a dialect of Python. And this is important because it means that it's not a static configuration file like a YAML file, but it's a full-fledged programming language. So you can define variables, have loops, conditionals, and so on. So here I have a small example of what this would look like. We can define variables, and we can define our own functions, and we could have loops here, for instance. And if we open a terminal and we use Tilt app, which is basically starting Tilt, and when we start Tilt, it will run this file. Apart from some Tilt output, we could see the output of these functions. So let's open Tilt here. Oh, wait, I'm not in the right folder. But I'm in the hello world, and if I start Tilt, let's see now. Here, if you ignore some of the Tilt output, you can see the code that I'm trying to execute in the Tilt file is this greeting, the filtering of the different people. And so basically it's just executing this code. So as you can see, you have a programming language that you can use to do stuff. So if we go to, if you have questions, just speak, otherwise I will be able to see it. If we go to a more complex example, let's have a small Go application. So in this Tilt file, we will define something called a Tilt resource. And a Tilt resource is any bundle of work managed by Tilt. This could be like a container image or a Kubernetes deployment, some local command that you have defined, anything. And Tilt will watch these resources continuously and rebuild them automatically when necessary. So it's just watching some of the files that you have in your file system, and it will run some commands whenever these files change. So in this example, we're going to define two different resources. One resource will be our Docker image for our sample application, and another resource will be a Kubernetes deployment that runs the Docker image that we create. So we can define the Docker image with this built-in function on Tilt, which is called Docker build. And here's the function. But as I try to explain here, this tilt function is really similar to what we do when we run Docker build locally. So this invocation, it will be the equivalent of running this locally. You just specify a name of the image, where it can find the Docker file, what's the context for building that Docker image. So it's like a built-in function that you can use to build an image. And the cool thing about tilt is that since we are passing here a context for building the image, tilt will watch this context, and whenever there is a change on this folder, the Docker image will be revealed automatically for us. This is our first tilt resource, the Docker image. And we said we were going to define two of them. The other one is here, which is the Kubernetes deployment that will run our app. And here we specified where Tilt can find the Kubernetes manifest with our deployment. And it has another built-in function called Kubernetes YAML. And whenever we call this function, the YAML code that we have will be processed by Tilt. So it feels a bit like running kubectl apply, because Tilt is going to apply that YAML. But Tilt will process the contents before applying them to the Kubernetes cluster. And it's smart enough to identify the image that we will use on this deployment or job or pod or whatever we have here. And if it sees that the image that we have here is the same image that we have defined on here, it knows that there is a dependency between those two resources. So whenever this resource will change, Tilt will reveal this one, but also this one, because there is a dependency between them. And here we are applying raw YAML. Like here we have a deployment. Let me show you. This is our deployment, so it's just a Kubernetes deployment. But Tilt has built-in functions for different things. So we have also built-in functions for customize or Helm. So you could even use manifest from those tools, and Tilt would know how to process them. Since we are deploying an example app that is an HTTP server, at the very end, we are telling Tilt to use kubectl port forwarding so we can access the application locally. In Giant Swarm controllers, normally we don't need this, but for the sake of this example, we need it. So let's go into the folder of this application, and again, start Tilt. And when Tilt is started, it keeps running. It's like a demo, and we can open the Tilt UI. So if I open the UI, I see here the different resources that Tilt have identified on my application. So in this case, we have our Tilt file. If we click here, it says that it was loaded successfully. And it also identified this other resource. So currently, it's building the Docker file and trying to deploy the application. That's why it's updating. And it's still doing its thing. Okay.
What about the Kubernetes resource?
Yeah, I think it's since it knows that the Kubernetes resource is depending on the Docker image, it's bundling those resources together. And here, if we see the output, we can see that it has built the Docker image, but it also has deployed the Docker image as a Kubernetes pod. So we can see here how the rollout of the pod is going. We saw that it took less than 1 second to be scheduled, 2 seconds to be ready. And also here we have the logs of our application. So it bundles together both resources into one because of the dependency.
Okay.
And yeah, so as you can see here, at the very top, we also have a link. That's because it knows that our application is exposing that port. So if we open the link, we can see the application running. Remember that we executed the port forwarding. So we are not doing magic here. It's like regular Kubernetes, but automated. So we have the example application right here. And if I go here to my application, we have here the main.go. It's a basic HTTP server. Let's change, for instance, this login message. Let's say.
Oh, sorry, can I interrupt?
Yes.
Can you tell me how the dependency, the grouping works? Because I don't see any reference between the two resources that bind them together.
Yeah. So here we have the image, right? It's called example go image. And it's the same image that you specified here. So Tilt is smart enough to understand.
So it's that smart. Okay, thanks.
Yeah. That's why it works with some of the built-in Kubernetes resources. But if you have some CRDs or things like that, it won't be able to understand. But since we are using here the built-in objects, it works.
But it's super hard to tell, right? It's like there's no hint. It's super hard to learn what is discovered and what not, because like there needs to be something under the hood that does that. So how do you know this works?
I think you can also, as far as I remember, you can also like imply, like explicitly define that.
Yes.
So you can either rely on the magic or you explicitly define it so that
the different resources have
full control.
The resources have a property called depths, and if you define the depths, you can define the different resources that resource depend on. So that will be explicit instead of implicit. Right?
Yeah, I would just imagine it's super hard to debug afterwards. Like if you make mistakes, it's super hard to find out where it is because of all the magic.
Yeah, probably the thing is that these don't change that often, right? You don't change the name of the Docker image that often. So I would guess whenever you get this working, it normally doesn't change. So I think it's fine. But of course, yeah, you have to know how it works. Otherwise, it just feels like magic.
Yeah.
And in the previous version, here, it wouldn't merge together both resources. You would see two different resources. But I updated Tilt yesterday, and now we have only one resource.
Yeah, and I'm just speaking a bit more about like a complex setup. Like if you would say we're creating a project to create the management cluster for Azure or AWS locally, and have tons of definitions there, then at some point it's easy to have a typo there or something there, and suddenly stuff's not working, and then it's kind of hard to find out why, I guess.
Yeah, that's true. Okay, anyway, let's continue with this. What I wanted to show you now is that we have our HTTP server. Let me change some code here. For instance, let's write here transform. And if I save this and I go back here, you can see that Tilt automatically picks up the change, and it's building the Docker image again, and it's trying to redeploy the application. And hopefully when it finishes.
Yeah, if you have a local registry, this gets really fast. When you use the remote registry, this is...
And also, as I will show you later, we don't even need to do this. Tilt has better ways of doing this, but I wanted to show you this to understand how it works. Okay, so the application got reloaded and our change is picked up. So yeah, it worked. But it's not it's not fast. So let's see how we can improve this. Another thing I wanted to show is that our Dockerfile here is building the Go application. And people suggest that you build your Go application locally on your machine, because that way you can reduce like the compiler cache, the Go modules caching, and so on. So the next folder talks about that. So instead of building the Go binary inside Docker, we will build the Go binary locally in our computer. And in order to do that, we need to add a new resource to our tilt configuration. So let's configure tilt to manage that compilation. And for that, we can use a built-in function called local resource, which is basically a resource that you define with a local command that you execute whenever some file changes. So in this case, we define a local resource with this name. This is just a name. You can name it whatever. And this is the local command that will be executed whenever this file changes. Here you can specify any number of files or folders or whatever, until we'll watch those paths, and whenever they change, it will execute this command. And also, we can also optimize how we build our Docker image to make it faster. And here we have a similar thing that we have earlier, but now I'm also specifying this only parameter. And the only parameter specifies the set of file paths that should be included in the Docker context, and the paths that tilt will take into account. So it's like a reverse Docker ignore, if you will. So I'm telling tilt to only watch for the folder that contains the HTML files and or compiled binary. I also have to change the Docker file. So instead of compiling the binary in here, I will have to copy the binary from my machine to the Docker image. So let's see how this works. Again, we run tilt up, and let's open this again. And now we have, instead of 2 resources, we have 3. We have the compilation, we have the Docker image and the Kubernetes deployment, and the tilt file. So if we go to the compilation, it runs the compilation command. And here we have the same as before, which is building the Docker image and deploying the application on Kubernetes. So the same as before, if we come here and we write something here, back here, you can see that the compile resource got triggered and the Docker image got rebuilt and redeployed. And it got much faster than earlier because, yeah, we are reusing different cache layers locally, and yeah, it was pretty fast. And all change is right there, and the application is still working as you see here. But still, we are rebuilding the whole Docker image, and we are rolling our deployment or Kubernetes deployment. So a new pod needs to be created every time we change the code. So that's not good, and we can make it better than that. So let's go to the next folder that I have here prepared for you. And on this case, here we have the local resource, like the one I just showed you. There are no changes there. But as I mentioned, if you see the logs in the tilt UI, you could see that on every code change, we are compiling the app, building Docker image, pushing the Docker image to a registry, and creating a new pod. Okay, this works, but it can take a while. And tilt supports all reloading files inside a running container, so we don't have to do all those steps. We only need to compile our application, copy the binary to an already running container, and restart the process running inside the container. So we don't create a new Docker container, we don't create a new pod, everything is still the same. We just swap the binary and restart the process. And for that, there is a built-in function in tilt, which is called docker build with restart. It's not really a built-in function, but rather a tilt extension. So if we go to this page, you can see that there are extensions. It's the documentation on how to use them. And the extensions basically are defined on this repository. We have the list of the different extensions. But currently, the extension system is really bare bones. So it's basically copy and paste managed by Tilt, because there are no versioning or releases or anything like that on the extensions. So it's as good as copying and pasting some code, but anyway, let's use it. So here we load the extension so we can use this function. And instead of calling docker build like before, we call docker build with restart. And it's similar but different. In this case, we specify the name of the Docker image, the context, and we have to specify what's the entry point. And this is because we need to tell Tilt what's the binary it needs to run when restarting the process. And that's the one that it needs to be run. And also, we have to add this bit here, the live update bit. And we are telling Tilt that it needs to keep in sync these two folders between the local machine, my local laptop, and the Docker image. So whenever we change the HTML contents or whenever we change the Go code, it will automatically copy those things into the running container, but it won't recreate the Docker image or the Kubernetes pod. So let's see how this works in action. First, let me show you here one thing. If you see here, this is the previous example, okay? And here we have a pod here. This is a pod ID from Kubernetes. And this ID is different from the one here. So that means we are recreating a new pod every time we change code. And now, if we try this approach, let's see. Okay, so the first time that we are starting Tilt here, it needs to go through the whole thing. So it's compiling, building the Docker image, pushing, creating the pod, and so on. Here are the logs of our application. But now, hopefully, if everything works as expected, if I come here and I roll right there, and I come back here, it's compiling. So it needs to be compiled, of course. But now, if you can see in the logs, instead of building the whole thing and redeploying our pod, it says that it's updating an image and copying the file inside the running container. It tells you which is the file that changed. In our case, is the Go binary. And it tells you that it copied from here to inside the container. And as you can see, the change took 0.2 seconds. So that's pretty fast to me. And you can iterate now on this, and try to get more. And it will continue doing that. And the feedback loop is pretty fast. You don't need to go through all the hoops. You need to build the Docker image and roll out your Kubernetes pod. So I think that's pretty good. And I think that's it for the demo. There are more things that I want to show you now, but any questions so far?
I have a couple. question one: how did you specify how Tilt connects to Kubernetes?
Okay. What I did here is that I cheated a little bit. And previously, beforehand, I created a new kind cluster, which I called Tilt. Could be named whatever, but I chose Tilt because I'm really original. And Tilt will try to use the current context that you have, and it will try to deploy there. So if I, for example, do this, and I create a kubeconfig for Ghost, so my context points to Ghost. Okay, now we are pointing to Ghost. If I do this now, fail, because by default, Tilt won't allow you to use some random context. By default, it only allows you to use kind, micro, CAPZ, and some other things, but that's it. That's to avoid you messing up some production cluster. You can change this with this command. You can add new allowed contexts, but by default, it won't work. But yeah, answering your question, it will try to use the context that you currently have.
And second question, is the Docker image, does it need to be any special? Because normally when you run the command, if you run your Go binary as the entry point, it gets the bit number 1. And if you kill it because you want to replace it, in theory, the container dies. How does it work? Do you know?
I'm not sure about that. My Docker file right now is just this, so it doesn't contain any magic. I'm not sure if internally it's adding any. I think it adds some what's it called, with one process to manage this, because it needs to handle the restart as you mentioned. So I think it on the fly it will use that process instead of the one that we.
Yeah, so it's another magic happening. So you didn't do anything specific for that. Okay, thanks.
Yeah. The extension that I used, I mentioned earlier that it's just copy paste managed by Tilt. It got saved here properly, and the docs recommend you to commit this into your repository so that your teammates don't have to download it again. And so it is the same as copying and pasting from the extensions repository. Any other questions so far?
I have a question. Have you tried it with an operator, with Azure operator or something?
Yeah, I want to show you next what I did with an admission controller that I was working on. Yeah.
Okay. So are you also gonna show the CAPZ integration?
Yep.
Yeah, because that would be interesting.
So I was working on the admission controller that we need in Celestial. This admission controller will try to default some of the cluster API CAPZ types. And yeah, I was developing this locally. And for that, I created a tilt file. So what I did here is first, I'm basing some of the tricks that you see here on the tricks that I saw on cluster API CAPZ. But I added some targets to my makefile. So I have tilt app as a make target. And it first tries to create a kind cluster. So you have to do it manually. And also this kind cluster uses a local registry. So you don't have to use a remote one. And the cool thing about the local registry is that it helps you with the first time that you test your application. As we saw earlier, the next time you change your code, it won't try to push your image anywhere, but the first time it needs to push it somewhere. So it will help you with that. And the Tilt people provide a bash script to create a kind cluster with a registry. So I save it here. And this is the script that they provide. And it's the same script that Cluster API is using. So I can use this script to create a kind cluster with a local registry. But basically, my make target will create the kind cluster with the registry and call tilt app. And my tilt file is the following. Let me start tilt now. So this is my tilt file. What I'm doing here is loading the extension that I mentioned earlier, but also I'm loading another extension, which is called Deploy Cert Manager, because I need Cert Manager for my admission controller, because I need certificates. This extension is also used by Cluster API. And here I defined my own function to call kubectl apply, because later I want to apply some Kubernetes manifests. And I deploy Cert Manager, and then I will create the Cluster API and CAPZ CRDs. I'm using one of the releases that we have in our API extensions. And basically what I'm doing here is just calling kubectl apply, but using my local function to use the right context. And since I'm testing an admission controller, I thought that it would be interesting to test it together with our Kubernetes policies. And we have our Kubernetes policies bundled as an app in our app platform. So what I did is use app test CTL to convert my kind cluster in a kind cluster that contains our app platform. That way, I can install any app from our app platform locally in the kind cluster. So with this command, I'm installing the app platform. Then I install Kubernetes, and I install the Kubernetes policies that we have in JSON. Then it's pretty much what we already saw in the demo. Let's ignore this for now. I define a local resource to compile my application. I use the make target that I have for building my application. And I have the Docker build with restart to deploy the image. Here, since this is a project that I created with KubeBuilder, KubeBuilder contains customized manifests to deploy your application. So I'm using the customize tilt function to run customize on my folder and generate the YAML manifest that I need to deploy the application. And I added a couple of commands here that I wanted to show you. The first one is a local resource that I can use at any time to test the creation of an Azure cluster with my admission controller and see that things work. I will show you in a minute how it goes. And I also added a task to be able to run the integration test from the Tilt UI. I'm also using my Makefile targets for this. So how does it look like? Let's go to the browser. Oh yeah, I'm using the X. Should work. So it's running the tilt file, and the first thing that I told it to do was to install Cert Manager using the extension. So this code I didn't write it myself. It's an extension. Everyone can use it. Just copying and pasting. Then it will try to convert or to install our app platform in the kind cluster. And it takes a little bit, but it only takes time the first time that you do it. afterwards, if you change, you'll probably need to rerun the tilt file again. I don't know why it's failing. I don't know. Let me show you the CAPZ tilt file, and we can try it later on. So the problem with tilt and cluster API, we have two problems with tilt and cluster API. The first one is that cluster API started using tilt really early on. So there are some things in the tilt configuration file in cluster API that are no longer the recommended way of doing things, because new ways or better ways of doing things have been released since then. So they are not really up to date on that. And the other issue is that REST API is also trying to figure out the best way to use tilt. So different repositories or different providers will have different approaches to use tilt. So let me show you first the CAPZ way of doing things. In CAPZ, we have the tilt file, and we go to the very top. Here, REST API is like defining some settings. This settings is just a dictionary that you can define, and the different users or the different devs can override those values. So they know that maybe you want to test with a different Kubernetes version or with a different CAPI version and stuff like that. So those things are exposed like configuration values that you can override with a different file. But basically here in the CAPZ tilt file, we have some settings. These are the default settings, and they will get overridden by this tilt-settings.json file, which is a file that you can define locally, but is ignored by Git. So it's not in the repository, and every developer can define their own configurations here. So yeah, here we are just managing those settings. You can add more allowed context, as we saw earlier. And here we are defining some functions that will be called later on. For instance, we are defining a function to deploy the core components of cluster API. So here we are using kubectl apply to use one of the releases of cluster API and deploy it in the local kind cluster. Then it's patching the YAML that we find in the release to add some extra arguments, like to change the verbosity of the components or change some of the flags of those components. And these are not really important. And then here we have some Docker magic, I would say. Here you can see some bash scripts called start and restart and so on, copied from some tilt repository. And this is because when they created this, there was no extension for the restart process that I showed you earlier. So this was the way of doing it, but that's no longer necessary anymore. We also have a function called CAPZ to deploy CAPZ. And this is adding, as I showed you earlier, a local resource to manage the compilation of the CAPZ binary. And here we have the command to compile it. And here we have the explicit dependencies of what files need to be watched by this resource. So whenever a file inside this folder changes, this will be compiled again. And also, this should be familiar, the Docker build, so that the image is built by Docker, and then the Kubernetes manifest is deployed using the same Docker image. So this is similar to what I showed you earlier. But as I told you, here we are using some restart and legacy stuff that is no longer necessary because of the extension that I showed you. So here we are defining these functions. And if we scroll to the bottom of the file, it says actual work happens here, and here we are just calling these functions. So we are deploying the set manager, deploying the copy core components, and finally deploying CAPZ. Here it's creating some config maps and secrets that are required for CAPZ to work. And flavors is creating some Kubernetes manifests with cluster API CRDs that you can use to test locally a Kubernetes deployment. Like, let me create an Azure cluster with IPv6. So that's a flavor of CAPZ, and you can deploy it from here. So let me show you that. Let's see if this works. It looks like my computer is running out of resources. You can see it's similar to the admission control I wanted to show you. And while this is doing its thing, this is the CAPZ approach. But for instance, if we go to the cluster API repository, the core components repository, this is like a different approach, because it will tell you if you create a new provider, you don't specify a new tilt file in your provider. So for instance, Kappa, the cluster API provider AWS, doesn't have a tilt file. Instead, it has some settings file that you can use to override some of the settings and test everything locally. So what is expected from every provider is that you have a file. Let me show you. It expects that every provider has a file like this with the information regarding the provider. So Kappa has a similar file to this, and the vSphere one has also a file similar to this one, and so on. So it basically tells you that instead of every provider having its own tilt file, the parent cluster API project will be able to build all the different providers with a single tilt file. But as I showed you, CAPZ is not following that approach. So yeah, I think they are just trying to figure it out just yet. But I think with what we saw here today, it will be easier for you to understand what's really going on the tilt files. So this is the CAPZ tilt file. It's creating different services. It not only deploys the CAPZ controller, but it also deploys a Prometheus operator and a Jagger operator, because you can open Prometheus locally or Jagger locally to see the traces, for instance, of your operator. That's why you see all these resources in here. And earlier I talked to you about the flavors. The flavors are all these resources that you see here. So these resources are just local commands that you can run to create an Azure cluster using this flavor, which is just a set of predefined configuration. Like, let's create a cluster with a Bastion host, for instance. You can click here and it will be created for you. So it's a good way to add like tasks to your Tilt UI, so they are easily reachable. So here is my CAPZ controller. It's being deployed, but as you can see, this is really similar to what we saw earlier. And Here is trying to deploy. These are the logs from the different components in the CAPZ controller. And if I go ahead and change a line of code from CAPZ, it will work as the demo I showed you. It won't try to rebuild the image and redeploy everything on Kubernetes, but it will try to replace the binary inside the running container, so the feedback loop is very fast. Questions?
Are you using this already? Is it helping?
Yes, because when I change code, I don't need to do anything. It's automatically deployed, and you can see the logs in here. And also, I think it's very handy to run these flavors to test the thing locally without having to deploy anything. One of the things that could be improved is that here you can see the logs from the different controllers that are running, but there are no highlights, or like if there is an error, it's not highlighted, for instance. You have to see all the logging and figure it out by yourself, basically. But I think it's useful.
Maybe we pull in Luigi there.
Yeah,
or the thing that you mentioned, the human log.
Yeah, I got it because I was talking to the Tilt people, and they have an issue created for this. On the issue, they mentioned the tool that I shared this morning.
Yeah, cool.
But basically, the cool thing is that I have a kind cluster with our app platform. I can install an app, in this case, kubectl. And when I press a button here in the UI, I create an Azure cluster CR. And I not only see the changes that I want to see because I'm developing a navigation controller, but I also see the changes from kubectl, and I can see that they don't conflict or they don't have any issues with each other.
Nice. So it goes into the same cluster, and you can see the interaction, even if it's into projects.
The demo gods are not dedicated. And I also added a resource to run the tests locally, the integration tests that I have. And we cannot see it right now, but when you have a test resource, it's like the rest of resource, but of a different kind, because you have you can specify that resource is a test. So then later you can filter here the regular resources or the test resource, and you can just run the tests from the Tilt UI, and I think that's also useful.
If I can share, one thing I don't like about the CAPZ Tilt setup is that the templates for creating clusters have the name of the cluster hard-coded, so you can create only once of the same type at the same time, and sometimes that slows you down a little bit because it means that you have to delete the cluster. If you make a change, you need to delete the cluster and recreate it. While in general with giant swarm operators, I just create another cluster with another ID while the old one is deleting.
Yeah.
But yeah, not a big deal.
Yeah, it would be cool,
Also,
like if you could have here an input or something to add the name.
What's up? You want to say something?
just a small comment that it also blocks that multiple people cannot work on the same cluster if you have only one ID, right?
Correct.
Okay, last chance. If this time doesn't work, I will call it.
While we wait, Puya, maybe I have an idea for a suggestion for Ellen. It would be nice to group resources, because think about the templates. They are a group of things of the same kind. I would like to have them in a folder. So I normally don't need them, because I care about my resource where CAPZ is running. But when I need a cluster, I just click on templates cluster. Just a random idea.
Yeah, right. Yeah, I bet we're not the first ones who mention it. But good to reiterate.
Are there any other questions? Because you only have 2 minutes left.
Oh, it's doing things. It only took nearly 3 minutes. And here I'm creating kind with a local registry, as I mentioned earlier. Okay, so this is starting my admission controller. And this is the task that I have to create an Azure cluster CR and see if the mutating webhook worked. So let me go here. We can see anything because I didn't run anything. And now if I press this button, it will try to create it. And also it will show it to me to see. I'm actually adding some security rules in this admission controller, and we can see that the security rules have been added. We can see them here. But I know that Kyberno is adding a label to my CR with the watch filter label. And we can see the label here. So Kyberno actually worked. I don't have that in my CR. I can show you here. This is my CR and the Azure cluster. I'm not cheating. As you can see, I don't have that label. But when I create it, since Kubernetes is executing both mutating webhooks, I can see both Kyberno changes and my changes here. So I can test the whole integration, and every time I click here, I'm testing my admission controller. And I can see the logs of my webhook in here. So yeah, that's what I wanted to show you.